Welcome to this explainer. When we think about the extreme deep sea, it's so easy to just picture this dark, barren, lifeless void. But actually, looking at the latest research, we're seeing a thrilling, dynamic laboratory of evolutionary marvels. Today, we're going to explore the insane biological engineering required to exist at these extreme depths. We'll see exactly how life, finds a way.
Okay, let's dive into this. On the agenda today, first, into the Haddle Zone. Second, surviving crushing ocean pressure. Third, energy flow in total darkness. Then, predators versus deep-sea scavengers, sensing the unseen abyss. And finally, a summary of deep discoveries.
Let's jump right into Section 1. Into the Haddle Zone. The frontiers of extreme science. Now, looking right here at this definition, the Haddle Zone represents literally the deepest ocean trenches on the planet. We're talking about plunges ranging from 6,000 to 11,000 meters deep. To put that into perspective, that is nearly 7 miles straight down. So, as researchers, the baseline hurdles we're looking at down there include absolute total darkness, near-freezing temperatures, and just unbelievably intense physical pressure. These are the extraordinary environmental conditions that these creatures absolutely have to overcome just to exist.
Moving to Section 2, surviving crushing ocean pressure. Engineering the body. Just imagine the unfathomable weight of miles of water stacked directly on top of you. And this number brilliantly illustrates the extremity. Creatures living in the deepest trenches, like the incredible Mariana snailfish, literally thrive under physical pressure that is over 1,000 times greater than what we feel at the sea surface. At that kind of pressure, a standard submarine would instantly crumple like a stomped-on soda can. No way around it.
So you might be wondering, how on earth does the Mariana snailfish survive at an astonishing depth of 8,336 meters? Well, most surface-dwelling fish use a gas-filled swim bladder to float around. But at 1,000 times the surface pressure, that gas would just get compressed into absolutely nothing. So the snailfish completely tosses out that surface world rulebook. It engineered a soft, translucent, gelatinous body supported by flexible cartilage. It's an absolutely brilliant engineering solution because water is practically incompressible, matching the density of the surrounding water with this squishy, fluid-filled body instead of a rigid, air-filled one makes the snailfish entirely immune to the crushing weight of the ocean. It's a real game-changer for surviving the deep.
That brings us to Section 3, energy flow in total darkness, the ecosystem mapped.
Since absolutely zero sunlight penetrates these depths, there's no plant life at all. So how do these animals actually fuel themselves? Let's move through this step by step and see how this builds, because it's a completely bizarre and fascinating food web. Okay, step 1. Organic trash from the surface world, things like dead debris and sunken wood, slowly falls an incredible 10,500 meters down to the seafloor. Step 2, we meet the Hirundella gigas. This is a super resilient giant amphipod. Basically, it's a shrimp-like scavenger, but it has these highly specialized metabolic enzymes that actually allow it to break down and digest the sunken wood, turning it directly into life-sustaining energy. And finally, step 3. Top predators of the Haddle Down, like the Mariana Haddle snailfish, swoop in and eat those crustacean scavengers. So the energy is successfully transferred all the way from a random piece of sunken wood to a scavenger, right up to an apex predator, all in the darkest place on Earth.
And then, you have creatures with even more unusual dietary strategies, like the Scotta plains, affectionately known to us as the sea pig. I know, it kind of looks like a pale alien water balloon, but don't let that comical appearance fool you for a second. The sea pig is a highly effective deep-sea cucumber. It uses these little tube feet to slowly march across the abyssal plains, up to 6,000 meters deep, and it literally hoovers up the ocean floor. It processes massive amounts of mud just to extract tiny, nutrient-rich particles of organic matter. It's essentially a deep-sea Roomba. And honestly, it is a wildly successful survival strategy down there.
What's really interesting about this slide is how perfectly we, as researchers, can categorize these distinct deep-sea survival techniques into 4 main ecological niches. So you've got your active predators, like the cusk eel. You've got your scavengers, like that giant wood-eating amphipod we just talked about. You have your mud processors, like our new friend the sea pig. And finally, you've got your suspension feeders, like the deep-sea brittle star. Every single creature down there has mapped out a highly specific strategy to make sure they get enough calories in a world where food is a massive, massive luxury. Okay, moving right along to Section 4, Predators versus Deep-Sea Scavengers. Survival Traits.
Finding a meal down in the deep requires incredibly specialized, totally contrasting behavioral strategies. Just look at the two sides here. On one side, you have active predators, right? Like the formidable cusk eel or the Mariana Hadal snailfish, using high-energy, active hunting tactics to literally chase down their meals. On the flip side, scavengers and foragers like the giant amphipod or brittle stars, well, they don't expend their precious energy chasing prey. Instead, they rely on extreme patience, highly specialized biological processing mechanisms, and perfectly adapted appendages just to catch passing debris. It's that classic evolutionary trade-off, burning energy to catch a big meal versus conserving your energy and just waiting for a smaller meal to come to you.
And these niches are just incredibly specific. The Mariana Hadal snailfish reigns supreme as a top predator, sustaining itself mostly on crustaceans. The resilient eelpout fish actively probes the deep trenches, specifically hunting for bristleworms. Then, the cusk eel acts as this formidable bottom-dwelling hunter, targeting small invertebrates at a crazy 8,000 meters deep. And then, there are the deep-sea brittle stars. They're related to starfish, but they don't hunt at all. They literally just raise their long, whip-like arms up into the water column and suspension feed. They perfectly catch tiny passing plankton in absolute pitch-black darkness.
Now we enter Section 5, Sensing the Unseen Abyss, Bizarre Adaptations.
So I really have to ask you, how do you see when there is absolutely no sunlight? For that matter, how do you even breathe when the standard surface world rules of biology just completely begin to break down? Well, the answers to these questions are, quite frankly, some of the absolute strangest evolutionary adaptations ever discovered. Take the Nezumia, for example, a type of grenadier living up to 5,500 meters deep. It doesn't even try to see sunlight. Instead, it's evolved these highly specialized eyes, specifically designed to detect the absolute faintest traces of bioluminescence, that chemical light created by other deep-sea creatures. It literally turns the absolute darkness to its advantage. Meanwhile, its cousin, the abyssal grenadier, takes a slightly different approach. It cruises just inches above the seafloor, using an advanced sensory system and a specialized chin barbel to physically feel and taste the water. That's how it detects hidden carrion down in the pitch black. But perhaps the most alien of all are the Raditarsus sea spiders. These arthropods can grow up to the size of a dinner plate. And here is the truly wild part. They completely lack gills. No gills whatsoever. So the crucial point is, nature finds a way. Instead of gills, these massive creatures survive up to 7,000 meters deep by breathing directly through their own legs. I mean, no way, right? But it's true. They simply absorb oxygen right through their exoskeleton as they casually walk across the seafloor under extreme pressure, just searching for sponges. It completely, entirely defies our surface-level expectations of how an animal should function.
And that brings us to Section 6, Summary of Deep Discoveries, the researcher's takeaway.
When we look at all of this data together as researchers, a really clear picture emerges. First off, survival in the Hadal zone requires completely discarding surface rules. You just cannot survive here with rigid bones and gas-filled swim bladders. You need gelatinous bodies and flexible cartilage. Second, energy at the absolute bottom of the world doesn't come from the sun. Instead, it requires highly specialized processing of surface trash, like those scavengers using enzymes to literally digest sunken wood. And finally, absolute darkness demands alternative senses. You must evolve chin barbels to feel for food, highly specialized eyes to detect faint bioluminescence, or long whip-like arms to catch what you literally cannot see.
It really makes you step back and look at our world a little differently, doesn't it? If biological engineering can produce a fish that withstands 1,000 times surface pressure, or a giant spider that breathes through its legs, well, you just have to ask yourself, what other completely alien adaptations are still hiding right down there, waiting for us in the unexplored depths of our very own planet? Thank you so much for joining me on this explainer. Keep wondering, keep exploring, and I'll see you next time.